The number of men and women studying chemistry, physics and biology at college are given in the following table. The man is okay. So one of these students is chosen at random by a researcher. In events M represents man, W represents woman, C represents chemistry, and B represents biology. Right, so they need to talk about physics. Find the probability of W given B. Means find the probability of woman given biology. Right, so probability of W given B, we know that it can be written in a few ways. We can say that this is the same as probability of W intersect B over the probability of B. Or since we're also thinking of counting the number of ways, we can also say this is the same as the number of ways in which W intersect B can happen over the number of ways in which B can happen. Alright, and over here we can count that the number of ways of W intersect B total means the number of women intersecting with biology, means it's just a woman who take biology. And you can see that there are actually 20 women who take biology. Alright, and for the number of B means the number of people, or the number of people taking biology, you can see in total there are 32 men, 20 women. So the answer is actually 52. So the answer is actually 52 because there are 52 people taking biology. Right? 32 men, 20 women. Right? So the answer is just 20 over 52 and equals to 5 over 13. Alright, and that's for part 1. For part 2, okay, we are looking at the probability of B given W. So probability of B given W, first of all, this is equals to, this is probably again probability of B intersect with W over the probability of W. Alright, and the probability of B intersect W, as you can see, you should have known, it's just like what we can also say that this is the same as the number of B and intersect W happening over the number of ways in which W can happen, and the number of ways in which B and W, meaning biology and women, okay, is like what we found earlier, right? It's just equals to 20. Alright, the number of women in total is equals to 40. Alright, so the answer is just half. Okay, how about part 3? Part 3, we are looking at the probability of B union with W. This means we are talking about the B union W is B or W. B meaning the people who take bio, W meaning the women. So if you are combining all the bio and women students, right? So if you just look right, in the women we have 40 students, and how about any other people who take bio? Bio you have men, right? Men, so actually there are 32 men who take bio. So in total you are looking at okay, let me just look at show you the 32. Okay, which is actually you can also say it this way. You can say it's a probability of B plus probability of W minus the probability of B intersect with W. Right, so probability of B means the probability of biology students. In total we have 52. Right, the probability of women we have about 40. Right, and bio intersect with this one you can say it's just equals to 20 over 100, and the final outcome should give you 72 over 100, which is the same as 18 over 25. Right, alternatively what you can do, you just count, you add the bio and the women students together. Alright, you add you see that there are a total of 40 women and 32 guys who take bio, so total you have 72. Right, then 72 over 100, you can also get the same answer. Right, so that's also one way. Right, so alternatively, alright, you can say that the probability of B union W is just equals to 52. Sorry, not 52. You can say it's, so women, and you means women you have 8 taking chemistry, 12 taking physics, 20 taking bio, plus another 32 men taking bio. So over 100, you're just going to get 72 over 100, which is 18 over 25, right? So that will give you the answer as well. Okay, and next, State with which reason in this case whether W and B are independent. So there are a lot of ways in which can prove independence. So based on those, you know that to prove independence, you can either say that W intersect B is equals to probability of W times probability of B, or we can say that the probability of W given B is the same as a probability of W, right? And you can see that we can just use one. Why would you use this? Because it's already given. It's already one of the things that we found earlier on. So what's the probability of W given B? We actually found it earlier. This answer over here is just equals to 5 over 13. Alright, as we have found in the answer in part 1. But what is the probability of W? Meaning, what's the probability of women? The probability of women, you can see, is actually a total of 40 upon 100. What's the total of 40 upon 100? Right? So, actually, yeah, you can say they are not equal, right? You can say they're not equal. So, can we say they're independent? So, answer is no. So, this is just one way to say, since the probability of W will be is not equal to the probability of W, right? So, therefore, B and W, they are not independent. Okay, can? Right, so, okay, next. How about to show whether they are mutually exclusive? To show mutually exclusive, basically, one way you can show that maybe M and C intersect C will be 0, right? So if they're mutually exclusive means they can't happen to at the same time. So however, if you look at M intersect C, this means that we're looking at the number of men intersecting with chemistry, meaning we're looking at the number of men taking chemistry. Right? Does it mean that it's 0? So if you look at the diagram, the question is no. There are actually 12 men. There are 12 men who take chemistry. So 12 men who take chemistry. Right? So actually, that means the probability of M intersect C is not 0. The probability of men intersecting with chemistry, right, is actually equals to 12 over 100. Right? Or equals to just 3 over 25. It's not equals to 0. So M and C, right, are not mutually, right, exclusive.